trigonometric series, that is a0 plus a1 cos nx plus a1 sin nx, then it is a Fourier series. Fourier series is an example of a trigonometric series, but all trigonometric series are not a Fourier series. This can be proved by giving example of a f of x equal to a0 plus summation of an cos nx plus bn sin nx. Here we can't express n as a 1 by pi 0 to 2 pi g of t cos t, and as well as bn cannot be expressed as a of t dt. Here this function cannot be expressed as a Fourier series, so all Fourier series are not a trigonometric series. All trigonometric series are not a Fourier series. Now the third point is why we are using Fourier series. Because any function f of x, by expressing it into a trigonometric series, we can analyze the problems very easily and also understand them. Fourier series was first used by Joseph Fourier to find the solution of the Fourier for the solutions of a heat equation. So now we'll see how a Fourier series of period 2 pi can be expressed. So we can express the function as f of x equal to a0 by 2 summation of an cos nx, and value of n should be from 1 to infinity, plus summation of bn sin nx n equal to 1 to infinity, where a0 is 1 by pi integration of f of x dx, where limits are c to c plus 2 pi, and similarly an is equal to 1 by pi integration of f of x cos nx dx, and the limits are from c to c plus 2 pi, and bn is equal to 1 by pi integration of f of x sin nx dx, c to c plus 2 pi. Here we are putting the value of n equal to 1 to infinity, means changing the value from 1 to 3 as this 1 till infinity, and so now we are going to see how to integrate f of x sin nx. We can do this by using the Bernoulli rule of integration. So what is Bernoulli rule of integration? Means if there is an integration of uv, then we can express that into u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4, so on. Here u and v are nothing but f of x and trigonometric function. The term which is going to diminish is f of x, and that has to be taken as u, and the other trigonometric function will be taken as v, and u dash, u double dash, u triple dash are nothing but differentiation. U is nothing but the term that is initially given, and u dash is a differentiation of u, and u double dash is a differentiation of u dash, and u triple dash is a differentiation of u double dash. v1, v2, v3, v4 are integration of v. So now we'll see some of the problems. So here is an example to solve Bernoulli rule. It is this. So the example is the integration of sin nx dx, where the limits are 0 to pi. Let us solve it. So by applying Bernoulli's rule, where u is x and v is sin nx, so integration 0 to pi x sin nx equal to, so u as it is, integration of sin nx is minus cos nx by n, minus differentiation of x is 1, and integration of minus cos nx is minus sin nx and square, applying the limit 0 to pi. So taking 1 by n as constant and minus outside x cos nx, and the limits are 0 to pi. Similarly, taking minus outside, minus into minus plus 1 by n square sin nx 0 to pi. So applying the limit, x cos nx will become pi, cos n pi is nothing but minus 1 raised to n, minus 0 into anything is 0, plus 1 by n square. Applying the limits, sin pi is also 0 and sin 0 is also 0, so 1 by n pi minus 1 raised to n, taking minus inside, pi by n minus 1 raised to n plus 1. Therefore, relation of x sin nx dx is pi by n minus 1 raised to n plus 1. So by applying the Bernoulli's rule, we are solving this. We are solving this question, integration of 0 to pi x sin nx dx. So we can solve this easily. So here is another problem to solve Bernoulli's, to solve the integration using Bernoulli rule of integration. Here the problem question is integration of x cos nx dx. Limits are 0 to pi. It is similar to the previous problem. Let us solve it by applying Bernoulli's rule. So here u is x and v is cos nx. So we can see in previous problem and now also we are taking x as v, x as u, because that is diminishing after 1 or 2 times, after differentiating 1 or 2 times. So let us see, p by x cos nx dx equal to, so x as it is, integration of cos nx is sin nx by n, minus differentiation of x is 1, and integration of sin nx is minus cos nx by n square. And again we are differentiating 1, but it will be 0, so no need to write it again. Limits are 0 to pi. So taking the constant term outside and sin nx 0 to pi, so minus minus should take it outside, it will become plus 1 by n square, which is constant outside, cos nx 0 to pi. So applying the limit, we have already seen in the previous question, cos sin n pi is also 0, sin 0 is also 0, so we are eliminating this term. Now only applying 1 by n square cos nx. So by applying the limit, n square cos n pi minus cos 0, so 1 by n square, cos n pi is nothing but minus 1 raised to n, and cos 0 is 1. So therefore integration of 0 to pi x cos nx dx, you will get answer 1 by n square minus 1 raised to n minus 1. So again we are easily solve this problem, integration of x cos n x dx. The answer is this. So now we will solve the Fourier series, problems on Fourier series. Now let us see some of the problems on Fourier series. The problem statement is as follows. Find the Fourier series of function f of x equal to x in minus pi to pi. So the problem statement is as follows, that find the Fourier series of f of x equal to x. So previously there was a disturbance, so now we will see the problem. Find the Fourier series of a function f of x equal to x in minus pi to pi. Here the period is minus pi to pi, which is nothing but the period is 2 pi. So we already know that how to express the function whose period is 2 pi, that is f of x equal to a0 by 2 summation of an cos nx plus summation of bn sin nx n equal to 1 to infinity. Similarly here also, where a0 equal to 1 by pi 0 to 2 pi c to c plus 2 pi f of x dx. So now we will find the a0, and f of x is here f of x is x, so a0 equal to 1 by pi and minus pi, c is minus pi, and c plus 2 pi is pi, and f of x is x dx. Here we need not to apply the Bernoulli's rule, so it is a simple integration. So 1 by pi will be outside. Integration of x is x square by 2, and limits are minus pi to pi. So taking the 2 outside, x square minus pi to pi. So applying the limits, we will get pi square minus pi whole square. So 1 by 2 pi square minus pi square, so it will be 0. So we get a0 equal to 0. Let us find an and bn. To find the bn, we already know the formula. an. To find the an, we already know the formula 1 by pi integration of f of x cos nx dx c to c plus 2 pi. So here f of x is x, and limits are minus pi to pi. F of x is x, and cos nx dx here also is. So now applying Bernoulli's rule, we have already discussed. Applying Bernoulli's rule, we will get 1 by pi x as it is, and cos nx is integration of cos nx is sin nx by n minus differentiation of x is 1, and integration of sin nx by n is minus cos nx by n square, so minus pi to pi. So 1 by pi, taking the 1 by n outside, we will remain with the term x sin nx. Limits are minus pi to pi. So minus will become plus 1 by n square outside, cos nx minus pi to pi. So we know that cos pi, sin n pi, sin pi all are 0. So is 0. Now we will remain with 1 by n square cos nx minus pi to pi. So 1 by pi n square, applying the limit cos n pi minus cos minus n pi, 1 by pi n square, cos n pi is minus 1 raised to n, and cos of minus n pi is cos n pi, and cos n pi is minus 1 raised to n. So this cos of minus theta is equal to cos theta. We know that basic formula. So minus 1 raised to n minus 1 raised to n, this one will also become 0. So an is also 0. So now we will find bn. To find bn also we have already know the formula 1 by pi c to c plus 2 pi f of x, here sin nx dx. Here f of x is as per problem statement, f of x is x. So bn is equal to 1 by pi, limits are minus pi to pi, f of x is x, sin nx as it is. So these types of integration we can